this wonderful learning journey. During the past 6 days, we explored network pharmacology, molecular docking, pharmacokinetics, and molecular simulation through both theory and hands-on participation session. We sincerely hope that this workshop had added value to your research journey and helped you gain practical knowledge and confidence in these important areas. Today, we will continue with hands-on practical session on molecular simulation, followed by validation session. I request everyone to stay with us until the end as we have some important announcement regarding the online assessment and certificate distribution. Now, without taking much of your valuable time, I would like to invite Mr. Jay Mukesh to conduct today's practical session. Mr. Jay, the platform is all yours.
Thank you very much. So, uh, we should proceed for molecular dynamic simulation. I will continue where we have stopped in previous hands-on session on molecular docking. So here I want to let you know that you must have the system configuration of your laptop or your PC or any kind of workstation which you are using to handle these commands. I will during command I will let you know that why these commands or why these scripts are used to run the molecular dynamic simulation. But at the time when the system is very much required, I will tell you that you should not use this command in every PC. If you will run, then it may take a weeks or months and keep your computer or your system on. So please keep that in mind. So should I continue with the docking where I have ended up in the last session? Please let me know. Hello.
Yes, Jay, please start.
Okay. My screen is visible now?
Yes, Jay, it is visible.
Okay. Thank you, sir. So, in last lecture, this complex has been done. So, here I want you to let, means we have this file, biotin out.pdbgt.ligand, and this was the protein molecule. Someone in previous lecture has asked some doubt that the participant is not able to create the complex. Okay, so I will let you know that how to create a complex for molecular dynamic simulation after docking. Okay. Can I know the question of the participant so that I can clearly represent you what you should have to do? Hello. Hello. Sir, can I know the question which was asked tomorrow yesterday?
Yes, Jay, it is in the comment box.
Okay, sure. Please wait, sir. Some connection error is there.
Okay, no issue, Jay.
Okay. Yeah. The problem is that heteroatoms are there and the complex was not prepared correctly. Yes. So Sivraj, you have to prepare the protein molecule as I am showing to you. As I want to take you to some theory part that the Gromex, the software which we will use in MD, can simulate the receptor molecule or any amino acid sequence or any kind of protein molecule. Okay, so it has all the algorithms in background that can run and has all the configuration. But in case of ligand molecule, or we can say the compound which we have to dock with the receptor, we have to prepare all the files. So I will let you know that how to prepare those files, and then may your query may be resolved. Please let me know, and please follow if possible. Okay, so my screen is visible, so should I continue?
Yes, Jay.
Okay, okay. So lastly we have completed till docking. Okay, now you are having this complex. This was the docking score which was obtained. So this was the docking score, and this was the file which was generated. Okay, after that this biotin out.pdbqt was there. Okay, so now one of the main reason, Suraj, that you have performed. Okay, so one of the problem that you may face due to that you have taken this and this receptor as a complex as a forming a PDB file. Okay, so first after this, after performing the docking, you should split this file, as docking with the help of Autodoc Vina gives you the top 10 top scores, which is visible over here, 1 to 10 doc, doc poses. Okay, so you should uh, make 10 poses and take the best one, that is 1 0 1 to make the complex with the protein molecule. Okay, so I will let you know that how to do it. Just go to CMD and go to your folder. Okay, go to the folder. After that, just type the command. Write your PDB file name. This is the command: Vina split space minus minus input biotin underscore out dot pdbqt. Okay, and after that click enter. Okay, it will form these files, 1 2 3, all the 10 poses. Okay, okay, are you following me, Sivraj sir?
So can you please show us the command once again?
Okay, okay, sure. This is the command. I am highlighting the command. It is visible. Sorry.
Yes,
uh,
yes, visible.
should I paste it? I will paste it in the chat box. Okay, you have to change the name of the file from here in the command. So now my compound is biotin underscore out. So I have to change the name biotin underscore out. What this command does, split the input file into its original form. Okay. Now this is the this is the final output which we will get after the docking. Okay. So now how to make a complex? So what we have to do? Go to Pymol. Okay, go to pymol. After then drag your ligand molecule or your receptor molecule. Okay, after that first complex which has highest docking score, drag that. Okay, here you can see this is the position where the compound is docked. So in biology, this protein molecule, biotin, streptoviridin biotin complex is known as lamp, burning lamp. So why it is known as lamp, or it has given the name lamp? Because it is like lalten. So lalten lamp is the common literature name given to this protein. Okay, so this is some crazy wordings given to any kind of proteins. So that's not a matter. But this is the complex. Here the compound has docked. You can see. Okay. Now you have to make the complex. This is the complex, docked complex. So go to files, export structure, export molecule. Okay. Go to files. I'm repeating again. Go to files, export structure, then export molecule. Then click to save. After that, give your name like biotin underscore complex. Okay, and save is at pdb. Please save it as pdb. Okay, click pdb and save it. Okay, now that file will be used for docking. Okay, so I have already prepared that file by the different name. So I have given the name biotin complex md. Okay, so this is the final file which I will take as a complex. So Sivraj, you have the question that how to make a complex. This is the step how to make a complex. If you are facing the problem in the step afterward this, so there will be the problem in the ligand preparation. So I will continue, and please let me know if you have any kind of doubts. Okay. So now we should proceed with the molecular dynamics. Okay. So for molecular dynamics, actually my system right now I am using the laptop. My system is not compatible to run 100 nanosecond within the stipulated time period. So I have prepared the video in our college system, and I will let you know that what I have run. And after MD, the post MD analysis I can run in my system. So during that period, I will show you the video which I have recorded in my Linux system, which is available, or workstation. So please bear me with that. Okay. So docking, the first step was protein preparation. Second step was ligand preparation. Third step was docking, which we have performed. We have to take that file. We have to take this complex file, and just this is the another MD folder. So these are the folders which we are required. So these are some scripts which are required to run the MD run. So these are the Python scripts which are having all the coordinates, or we can say all the terminals to run the MD simulation. That we have to run the MD, that I have shown you the in theory part. I have shown you that it works on these formulas. So these files are the basics file which connect the server with the basic requirements. So these are the basic folders which are required, and by default you will have the different force field. So currently I am using charm force field. This is the folder of charm force field, uh, which is latest one and has all the latest calculations, and based on which we can get the best results in GROMATS. So what we have to do, just paste your complex over here. Okay. After that, we need to prepare a ligand molecule and the protein molecule. So now we are starting with the molecular dynamics. Do you have any kind of questions? Should I continue? and please bear me because so many steps are there in molecular dynamics that I have to explain you in less time. So can you share these files with us? Yeah, definitely. I will share you the files with share you the files. I have not shared you because its memory is quite large. So I will try it with talking with Sumit sir and try to share with you. Okay, okay, okay. I am continuing. So this you can see in my arrow that this is the file which we have taken, and all other files are already present in our complex file folder working directory. Okay, so just go to Chimera. This is not Chimera, this is only Chimera. Chimera X is different and Chimera is different, so you should install the Chimera also. Chimera version may vary, version may be 1.118 or 1.17 or 1.19, it doesn't matter. So just open the Chimera software. It may take some time to open in your system based on your system configuration. Okay. This is the interface, UI interface of the software. So go to files, open. Okay. Give the folder location. Okay, there is some problem. Sorry. As I am using the external drive, it will not run the MD. Okay, this is the folder. So just paste your folder location over here. Okay, these all are the files. Our complex is this one. Just click on open. Okay, this is the complex. So what does it has? This is the ligand molecule and this is the protein molecule with alpha, beta sheets and all. Okay, so go to select. First we will do the receptor preparation and after that we will do the ligand preparation. So for ligand preparation, for receptor preparation, you have to go to residue, go select residue UNIL. Okay, select it. This is the compound which we have docked. Okay, ligand molecule which we are talking about, and actions, ribbons, delete. Okay, delete the ligand molecule. So now what we have? Only the receptor. So after that, go to tools, surface binding analysis, then go to dock prep. Okay, please follow me. Go to dock prep. After clicking dock prep, this type of interface will be there. Uncheck incomplete chain sides, side chains. Okay, after unchecking this option, click on OK. Okay, after that, you do not have to change any kind of thing. Click OK. Then after that, if this the system is not given the selected by default selected the gesture, please select over here gesture and after that click OK. So you can see on the leftmost corner, bottom corner, doc prep finished. Okay, so do not click anything, just close this one. After this file, save as pdb. Okay, after that give name, please give the names as I have given it, as the script is edited according to these names only. Okay, please follow me. Write in capital REC. Okay, and just save it. Okay, anyone is having any kind of doubt, you can unmute yourself and please ask. Okay, this was the step for receptor preparation. Okay, after that I have to again open the Chimera. Okay, and open the chimera, file, open folder location, again open this complex. Okay. Now, this time I have to select the receptor for the preparation of ligand molecule. Okay. So action, atoms, delete. So delete the receptor molecule. Then tools, structure editing, add hydrogen. Just please click OK. You do not have to make any kind of changes. This will automatically add the hydrogen molecules. Then go to file, save as mol2. Okay, save mol2 and give the name LIG in capital. LIG in capital. Okay, and just hit save. Okay, now, sorry. Now you have this files, new files will be generated in your folder, that is leak.mol2 and receptor.pdbqt. Okay, till now, are you following me? Please let me know.
Yes, sir. Please go ahead.
Yeah. Okay. Okay, this is the final file for the ligand preparation. As I have told you that Gromex uses the basic data of amino acid and all that. So it has all the data, no, not all the data of the all the structures, or we can say molecules. As the molecules have sulfur, oxygen, carbon, nitrogen, and all other metals also. So it doesn't have all the coordinates. So we have to provide the coordinate file to it. So how to prepare a coordinate file for a ligand molecule? You can prepare with the help of uh, uh, one tool and online free tool. But for that you have it is not useful in Google Chrome. So you have to use any other browser. For example, Edge or Mozilla Firefox. Okay. The tool name is Swiss Param. Okay. Go to the website. Please go to the older version, as some of the smileys are not supported in the latest version. There are some bugs, they are fixing it. So please go to the older version. It will redirect you to this interface. Okay, just drag your ligand molecule and paste it over here and submit query. Okay, within 10 to 15 minutes or within some seconds, based on your server number, it will show you the results. Okay, so we have to wait for at least 1 to 2 minutes till the server gives us the coordinate files of our ligand molecule. Okay, it has generated. So it will be generated topology file. I have told you in theory what is topology file. It is the coordinate file. Okay, so just click over lig zip. It will download the zip file in your downloads. Go to download, unzip that zip file first, extract all at the same location. Okay, just hit Ctrl A to select all, Ctrl C to copy. After that, go to our folder and click paste. It will ask you to replace. Do not replace. Please mark my words. Do not replace the file destination. Click skip. Okay, it will replace our ligand molecule. So we have optimized, added hydrogen. So we do not need to replace the ligand molecule. Okay. And please make sure that unnecessary tabs should not be open during this process. It may confuse you. Okay. So these are the basic requirements. So now I have told you to install the Ubuntu system. So now I am doing all the commands in Ubuntu. And if you have any kind of doubt during the session, please feel free to ask. Okay, so I will open the Linux PowerShell at my folder location or working directory. Okay, now you can see that my folder location is there. Okay, now first and foremost thing, my Gromex is installed or not, that I can check with the help of command gmx. Okay, after hitting gmx, it will show me Gromex gmx 2023 Ubuntu version. So I am right now using Gromex 2023 version. Now the Gromex 2025 or 25 was the latest one. So based on your system, you can download the Ubuntu system. The everyone has downloaded Ubuntu Gromex in Ubuntu in their Ubuntu system.
Yes, sir.
Okay. So okay, I want to let you know that if you are using rebootable Ubuntu system, the some commands will be different, may not work. It will work, but you may face some kind of error. Okay, so in if you are using rebootable system for Ubuntu, so you need to have paste your command with the help of Control Shift and V, not clicking the Control V. There are some kind of these kinds of some of the mistakes which may occur. Okay, so please keep that in mind. And now I am using the uh, uh, Ubuntu system in my Windows. So I am giving you the commands accordingly. So first and foremost command which we have to do is this one. This is the source command. Okay, this is the source command. Is it visible? Oh, sorry. This is the source command. We are sourcing our system to take all the Gromex file which are available at this folder location. Okay, just click this command and hit enter. It will now onwards it will do its work from the gmx folder in your system. Okay, now the first command, that our ligand preparation is done or not, we can confirm with the help of perl short underscore mol 2 underscore box. Okay, oh, my perl is not installed in the system, so it is not giving. Please wait, I have to connect the perl. Okay, please wait, I am solving the bug. Okay. Uh, yeah, now it is running. Okay. The command is this one. Ah. Perl short underscore mol 2 underscore bonds dot pl. Actually, I have done the bond instead of bonds, so bear me. Bonds dot pl leak dot mol 2 leak dot mol 2. So this is the command. After hitting enter, it will tell you 32 atoms are there and 33 bonds are there. So this will show you the interactions which is occurring with the ligand molecules. So this is the confirmation that your leak file has been prepared properly. So now we have to apply the force field. The first and foremost thing which we have to do is applying of the force field to the complex molecule or the receptor molecule. So how you have to do? With the help of this command gmx pdb to gmx. Means these commands tell you that commanding pdb to gmx, that -f is to select the folder or file rec.pdb space minus infinite ignh. So it is the command which is used to tell that integrate my receptor pdb, please integrate my receptor with the gromex folder. Okay, after hitting enter, it will ask you. Okay, I will let you know what this command does. This was the command. Okay, what this command, select the force field, asking for the force field. So these are the default force field in 2023 which is there, which is amber. I have discussed earlier, there's a different type of force field are there: amber, charm force field, and its gromex force field. Okay, and oplass. Okay, these are the force field. But in the folder I have given you the file, I will provide you the file. So select one as it is the latest force field. Select one and hit enter. After that, it will ask you that which type of water molecule you have to use in your simulation system. So it it is recommending, gromex is recommending me to use tip 3p. This is the commonly used type of water force field used for molecular dynamics of any protein ligand interaction. So select one and hit enter. This will generate the topology file, and after that, okay, one of the main way to find that your command has been run or not is with the help of this funny comments, or we can say any kind of quotes will be represented. These quotes are at random. If any kind of quotes will be visible over here, then it shows that your command has been run successfully with no error. Okay, now it has formed the topology file for the receptor. We have prepared the topology file for the ligand molecule with the help of that Swiss Param online tool, and now with the help of gromex we have prepared the receptor. This is the main function of this file. Now we have to make some editing in some of the files, as now we have some different files available in our folder. That is, as you run the files, new files will be created in the folder, and this topology file for the receptor, and ions dot leaked of idp is for ligand molecule. Okay, so I will continue and let you know which new files will be generated and how we have to make the changes. Now, first change that we have to make to run successful MD is change in the configuration file of a compound of a receptor and the ligand file of a ligand molecule. Okay, so just click GEDIT, conf.grow. It is the file available over here, conf.grow, conf.grow, okay, conf.grow to leak.grow. GEDIT is the common tool used by the editing of the file with the help of command line. In some of the systems, if you are the new user, this is not installed. So just click sudo apt install GEDIT. It will suggest you. Okay, Gromex will suggest you automatically what command you have to write for downloading GEDIT. Just click GEDIT, these two files. Okay, now in editing software, you will open conf.grow and leak.grow. 1 minute. File is not generated only. I think I have done a mistake. Please wait. Due to my folder location, my grow file is not created. Please wait for some time. I will resolve the problem and let you know. Okay, now it has been generated. So our command was GEDIT configuration and ligand grow file. Okay, so what you have to do, you have to copy all the file over here till the second last line. Just copy it, go to grow, go in end of the file. After that, hit enter and just paste the sequence and align it with the file with the help of backspace and the space. Okay, after that, go in and you will see that how many lines are here. That is total 1857. So you have to subtract 3. You have to subtract 3. That is 1854. So you have to write that how many files are there. How many molecules are there? 1854. You have to subtract 3 because this is the line 1, 2, and last one line, this one. which is of not recognized by the GROMAX. So you have to subtract 3 from the final whole line, okay, and write it over here. So this will confirm that how many molecules are there for the future topology file creation, okay. After that, make changes, save it, and go out of the folder by clicking cross button.
So can you please repeat this last step? How did
Hello,
you open those files, sir? So can you please repeat the last step?
log file.
So these files, from where did you open this?
Okay, with the help of gedit conf.grow this command. If you are using it first time, you have to install the gedit. This one, gedit. You need to install this gedit. Okay. After clicking it, it will directly open it. Okay. You can also manually edit it with the help of Notepad also. Okay. This is the shortcut to use it with the help of command. Okay. Any doubts?
Yes, sir. After opening, what do we have to do, sir? Can you repeat it, please?
Okay. Actually, I want to let you all know that if I perform any one step, then I have to start from the beginning. That is the problem. So I will let you know what.
It's okay, sir. I will watch the recorded one.
Okay, no problem. I will let you know what the changes that I have done. Okay, that I can show you. That leak.grow file. Okay, it will show this kind of ligand interactions. Okay, so just copy the ligand interaction. Go to comp.grow. Go in the end. Okay, after this is not represented over, just hit enter and paste your ligand details. So what we are doing here, configuration file of receptor is created by with the help of GROMAX. Okay, we are giving our ligand details to GROMAX, and after that you have to go in the end and see how many number of lines are there. 1857 in my right hand side, it will show the number of lines. Okay, after that go in the beginning, as the 3 lines are not of useful, so remove the total number of lines minus 3 and write it over here, 1854. Okay, now moving forward, now I have to edit the topology file. Okay, this is the topology file, and what I have to make the changes is to I have to make the changes over IDP. Yeah, here, hit enter twice. After that, add these lines, semicolon, include okay, you need to include this line, that topology file is generated for the receptor molecule, which is represented over here. That is, this is the force field, this is the normal chain and chain details. Okay, so now what we have to do, we have to give the command that ligand molecule is also there in your receptor. If you will not include this line, then your MD simulation will be run only for the receptor molecule, not the complex molecule. Okay, please make sure. And one more thing that we have to make change, go to bottom. Okay, after at the last line, here click enter, write LIG in capital, space, tab 1, and with the help of space and tab, align it with the one molecule. Okay, align it with the one written above this line. Okay, aligning lig and one. Okay, these are the main changes that you have to do and save the file. Okay, another file, if the files are not prepared properly, you can check some of the important file, that is leak.itp. Leak.itp, you must see this line. It will be there if you are using the Swiss param. This line will be there. Okay, no need to make any changes. This is the confirmatory step that your ligand is prepared or not. Okay, just confirm and move forward for the next command, which is now. I have told you that we have to give the boundary constraint. Okay, in theory part, I have told you that we need to give the boundary constraint for the molecular simulation or box simulation. Okay, so this command which I am typing over here will be used to generate a fixed shape and 3D conformation for the boundaries to perform the molecular dynamic simulation. So command is gedit, GROMAX, GMX, edit, configuration, -F, that is folder, and file configuration dot grow -O output, that is box, -C and -D for the parameter file, that we have to give one bit of space between each water molecule in the grid box, and the shape, that is do decahedron. This is the shape. Dodecahedron is the most similar shape to the circle. Okay, so hit enter. After that, you will see the system's file will be generated, that is of XYZ coordinate in nanometer, with this box volume, box all the details, box center, all the angles of each and every water molecule will be provided over here. So you have successfully created the boundary constraint for molecular dynamic simulation. Okay, after this command, another command which is used to add, this is the command that we have given the boundary constraint. Okay, please correlate me with the theory part also, so you can understand that, get at each and every step why we are using these commands. Okay, so this we have given the boundary constraint. Now with the help of command gmx solve solve it -cp box.grow yes space okay. What is this command shows? That gmx add solvate to this grid box with the help of space 216.grow. This is the standard file of a water molecule used for the GrowMax. Okay, in topology file, and generate the file box underscore sol.grow and hit enter. Okay, this is the code now GrowMax has given to me, and it confirms that my solvation is done. Okay, after this solvation, you can visualize the solution with the help of this Pymol. Box underscore sol.grow. Okay, this was the final file till now which we have generated. Just like this, so we can visualize it properly. Okay, this is the solution box which we have created. Okay, it is having the ligand molecule also over here. This is the ligand molecule, and this is the receptor molecule, and this is the solution which we have added in our boundary constraint. Okay, so this is the visualization that what we have done till now. Okay, it is not in center. With the help of next commands, it will come to the center, and whole MD will be simulated in center only. So till now, anyone is having any kind of doubt, please you can ask. Okay, should I continue? Okay. 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 I'm continuing with the next step, that is GMX gromp minus F ions dot TPR minus P topol dot top minus what was our last command? Box underscore show. Please wait. Minus P topol dot top minus. This was the different command. Okay, error is there. File name is different. Please bear, we have to make the changes at the time of MD run only. Okay. Okay. Now it has run the command. That this command, okay, another error. Okay, please wait. Some of the file is not generated in my system because of my system configuration. Please wait. I am taking the file from the folder which I have generated in my system. Okay. Please wait. I will let you know that actually my system configuration is not compatible right now. So I have prepared the same file in my system and I am showing it to you, and try to run this command in those file only. Yeah, this is the final MD file. I am creating. Please wait. Yeah. Now I am creating the file. Actually, what is happening that my RAM is less. So my RAM is 16 GB, which is not compatible to run all this command one at a time in my system. So I have run my command in our working system directory, and after that, okay, these are the files which are generated over there. We will continue over here, and new files will be generated in this only. PowerShell. Okay. We have to give the source first. After that, this last command. Last command was already there. Yeah, this was the last command. Yeah. It will generate an ion.tpr file, means ions which are generated, which are having the parameters. Okay. After that, with the help of other command, gmx gen ion minus s ions dot tpr minus p to generate the topology dot top. Okay, so it is not running in my system. Please bear me. Uh, think there is the problem. I think please give me 2 to 3 minutes to fix this problem. Okay. Now, oh, sorry. Okay. Now I got it. Okay. This was the command. GMX gen ion generates ion.tpr to topol top concentration. I am writing the concentration to 0.01, which was wrong. I have to write the concentration to 0.1. Neutral box.grow to gone clear. Okay. After hitting enter, it will ask me that how you want to create a molecule. So what we should do? What do you suggest that we have to prepare the whole dimensions only in the water or with the ions and all the molecules? So we should go with the SOL solution, which contains sodium ions, potassium ions, and calcium ions based on the receptor molecule and the water ions also. So we have to select the 15 number, which is Sol, and hit enter. Okay, it has created the sodium ions, chlorine ions into the system. Okay, these commands adds the different kind of solvates, or we can say mimicking the system system. So biological system, it will generate the calcium molecules and sodium molecules into the that grid box, or we or grid dimension. Okay, after that the next command is this is the command which is used to generate the energy step. So I have told you during the theory session that we have to get the molecule or the complex to its ground state or stable, most stable state. With the help of this command, it will generate a files to go to its energy states. Okay. Okay. After that, you have to write just one command this is the first step for molecular dynamic simulation. So GMX MD run minus V minus diff energy minimization. Sorry, I think there is some error in my system. So based on my, as I am having only 8 threads in my system. Actually, greater than 32 threads in my CPU is required to run this command. But I am running this command to show you that this is the each and every step energy calculation which is done. So this is the each and every molecule in my complex or this system which is having water, receptor, ligand, sodium ions and calcium ions. It will generate the energy and calculate the energy and give you the final energy output to perform the further MD steps. Okay, are you following me? Anyone is having any kind of doubt, you are feel free to ask till this energy minimization step is going on. You can ask the question. Means MD run is having so many steps for MD run and during MD simulation. So what you have to keep in mind that you should write the commands correctly, file name, folder name, output name correctly to run your command. If you will write the name wrong or in different format, then the MD run will be stopped or error will come again and again. Okay, so keep that in mind. You have to write the command correctly only. Okay, so it will take some time to generate the energy minimization step. After that, I will get you to the next step of MD run in my system, and I have generated the videos, so I will let you know from that videos only. Okay, and I will give you some commands for the post MD run. So after the MD run, how you should prepare the uh, results, that RMSD, RMSF, RG, all that type kind of results which are there in publications. So it will be generated over with the help of final after this step of final MD run. Okay, so these files are generating over here, and yeah, so now it has given the total potential energy is -4 of my system plus minus 0.5, and my force field is 9.94, which is quite good. And with atom, total number of atom is 1828. So I am having 1828 total atoms in my this system. Okay, and with the force field force of 2.14 Armstrong. After this, we have to make some changes in the grow file that I will show you. This one, not this one. Okay, in the index file. Okay. Now we have to now till now the energy step is completed. Now we have to prepare the index file. Indexing means we have to do some type of documentation for the Gromex software to let it know that how we have to run the MD in further step. Okay. So command for that is gmx make ndx -f with the folder link.grow -n index. Oh, sorry, not I is not capital. Underscore lib dot ndx. Okay. Oh, sorry. Okay, ndx version in my system is not supporting. After means after this we have to. Okay, I will take the command from the command line. I think I am getting mistakes. Okay, system is not supporting. Please wait. Yeah. Yeah, it is asking for the system files. Okay. Now, what does this command do? Make ndx -f leak.grow -o index underscore leak.ndx means with the help of ligand file, make ligand.ndx file for our next preparation. So what is our next preparation? I have discussed you during the simulation step only, simulation theory, that after creating a grid box dimension, we have to after considering the dimensions for the MD simulation, we have to give its pressure and temperature to excite that complex to its excited state and go with mimicking the body environment uh, or the biological environment to give the molecular dynamic simulation. So what we have to do now, we have to select the atoms and groups based on that. So we have to select this option, that is 0. 0 option is system, that whole with ligand. We do not have to do the molecular dynamic simulation of receptor or ligand individually. So we will take 0 as the system. Whole environment we will take, and with the help of exclamation bar, not the hydrogen atom, okay, or water atom, and hit enter and hit Q, it will go out. Okay, now index file is generated. Now this index file will be used to run the MD. That now my system will not support to run those MD run, so I will redirect you to the video that how to run the MD uh, in your high configuration PC. So this was the video. I think. Yeah, this was the video that I have prepared to show you that how to run a MD. So okay, till now the work that I have done, I have transferred it to my Linux system. After that, I will open the terminal at the Linux, and with the help of the commands, I will first here give the source that I have explained you in the first step, and this is the file provided to you. I will provide the file. So what this file has, that all the configuration details that you have to do the excite the molecules present in the whole grid box dimensions, all the atoms and molecules with its accuracy. All the details is given in nvt.npt. nvt, can anyone say what for what purpose we are using nvt in I have discussed in theoretical portion. So what is the use of nvt during molecular dynamics? Anyone knows about it? I have discussed during the theoretical part. Okay. So NVT is used for temperature. So it will generate a temperature of 300 Kelvin, and after that we will generate the topology environment file for the NVT run. After that, the final MD NVT run. So these are the total steps which we have given, that is 100 picoseconds. Normally NVT and NPT is run at 100 picoseconds only to make the files. Okay. So you can see that our system is having one GPU with 32 OPMM threads and all. So our performance is basically 374.7 nanosecond per day. This is the our system configuration. So I have told you that you should have the system configuration. After NPT, we are preparing for after NVT, we are preparing for NPT. That is for pressure. We are giving the file, the coordinates that you should prepare the pressure, excite the molecules with the help of providing 300 kilodalton, 300 Kelvin temperature and 1 Pascal of pressure. So it will generate the MD run generating files. Okay. Now it has generated the NPT file. After that, we have to do the MD simulation. So here is the final step for MD simulation. So you have to make the changes according to your study. If you want to run the MD for 10 nanosecond, so you have to make changes in this calculation also. So if you want to, this is the file which is generated for 100 nanosecond, and according to that dividing it by 0, converting it to picosecond and dividing it with the steps. Okay, how many steps are required? So for 100 nanosecond run, you required a 5 crore steps. Okay, so what I have explained you in theoretical part, that the Gromax system or during MD simulation, you will calculate each and every 2 femtosecond for each thread, each atom in whole system. So it will calculate 5 crore times at 2 femtosecond frame the changes are making at the time of vibration and the frequency provided to it, provided to complex. Okay, so this is the final MD run. So I have shown you for 100 nanosecond. After that, we have to prepare the MD compatible files with the help of this command. After that, we have to hit for the final MD run. So this was the command we have optimized for our specific GPU. So you can make the changes in this command according based on your system configuration. After that, MD run will start. And as you can see, I have started at 10 a.m. and it is showing that about it will take 5 o'clock to complete, 5 p.m. to complete. Okay. Well, or not, that I'm not able to see. Please wait. Okay. So it is showing 1654. So it is taking about 5 to 6 hours or greater than that. Okay, 6 hours to complete the run, MD run. So this is the I have stopped the recording as it will keep recording for next 5 hours, 5 to 6 hours. So I have stopped the recording. After this, I will show you that how to perform the further step of making a movie or MD simulation movie. This is the video which is generated in the same system. After the MD run, what it has shown, please wait. Okay, what it has done told me that it has taken 6 hours and 42 minutes and 50 seconds to run this molecule complex with the help of this command. So after 6 hours, I have examined for the video configuration. So you can make the video with the help of Chimera X. Okay. Why it is not showing? This video is not running. This was the command. This file is not right now. Actually, this video has hanged my system, so it is not running. Okay. Okay. Till now, I have explained you that it has taken this much of time. These are the steps for movie preparation. So I have told you that at the end we will generate the file with its with the center. So in at the time of first file or growth file which we have generated, at that time the molecule was shifted to one of the corner. So with the help of this command gmx trajectory to center, we can compact the molecule towards the center. This was the command which we will use to generate the center XTC file or final MD file to make the molecule visible to us in the center. Okay. These are some of the steps which we have to prepare the PDB file, as the Chimera X is only opens the PDB file and XTC file. So we have to convert the trajectory files to PDB file. So these are the some of the steps which we have to perform to convert it to the PDB file with the help of Chromex. Okay, protein data bank file, PDB file format. Okay. After that, yeah. Okay, yeah. You have to go to Chromex, Chimera X. Open your Chimera X. Open the folder location. Select the file start.htc. Start.pdb. The PDB file which is generated with the help of these commands which I have shown you in the file. So these are the protein molecules. Sorry, I will tell you what this file contains. Okay, start.pdb file contains the receptor, water molecules, sodium ions, and calcium ions. And with the help of start.pdb, md.center, you will see this file. Okay, what we are representing over here, or what you can see, that all the violet balls which are appear over here, or molecules which are appear in the screen, is the sodium ions, and small red molecules are water molecules, our receptor and our ligand. So we need to open the file, XTC file, and this file has all the trajectory of the molecules. So the file size is very large. So for this molecule, it has generated 1.2 GB of the file. So after that, it will take some time to load the file. When it loads the file, it will generate. Yeah, we can change the color or the other requirements based on our visualization. So we have fixed the visualization that I want this rainbow color for the receptor molecule, and the normal visualization of the ligand molecule and the complex. And I will hit for the recording of the MD simulation. It will start in some time. Okay, it will start now. Yeah, this is the real-time MD simulation, which we can see that how our molecule is remain into the pocket and can be visualized with the help of this. In some high impact peer review journals, a journal may ask for the video also. So we have to provide the video at the time of when reviewer asks for the simulation videos. Okay, after the MD simulation, with the help of commands, I will show it to you. Some of the commands are for RMSD calculation. This is the command for RMSD calculation. After that, this is the calculation for command for calculating RMSF, radius of gyration, calculated with the help of this command. And this is for SASA. And last one, hydrogen bonding. Okay, these are the common commands. So I will let you know that which kind of files will be generated. So with the help of command line, I will let you know. So, okay. So the file which was generated is this one, rmsd.xvg. Okay, this was the result of RMSD. What does this show? That till 100 nanosecond the molecule remains into the pocket. Okay, this was the protein molecule RMSD. After that, there are different methods, different calculations for RMSD of the ligand also. I have done the RMSD calculation of the backbone, that during MD simulation the protein unfolding is there or not can be observed with the help of this graph, that it remains throughout the a constant position throughout the MD simulation. And with the help of this command, we can see that also the ligand do not uh, transform into the another form, or stretching bending is more, and it stables during its whole MD simulation. Okay, and after that, with the help of the command final, this is the final command for protein ligand RMSD visualization, that this is the stability of the molecule during the 100 nanosecond run. So we need to give the XVG backbone file only for the RMSD calculation in preliminary studies. Okay. After that, based on your study, you can select any kind of RMSD you require. After that, we are performing the RMSF. RMSF is used for loops, or the sorry. Find the loop residues. Okay, so with the help of this we can find the loop residues, that how many residues are generated during the MD simulations, that how many residues are moving. So during MD simulation, I have told you that alpha, beta sheets and alpha chains are there. The molecules which vibrate at their own frequency, the last tail molecules of a receptor molecule, a receptor which moves in all the direction in 3D plane. This graph shows that how many new residues are formed. Okay, we need to generate accordingly. And after that, radius of gyration, this is the file that confirms, or this graphical representation confirms, that during 100 nanosecond run the protein unfolding is not happening. So protein remains, or the protein and complex remains into its stable form. If the protein unfolding will occur, this graph will fluctuate to 5 to 6 nanometers. So it will not generate a stable this kind of graph. So this confirms that our protein unfolding has not occurred during the full MD run. After that, next command is for SASA, solvent accessibility surface area. So during folding and unfolding, what are the changes which are done during in the perspective of area, surface area of a protein molecule can be depicted with the help of this MD simulation. The surface area should be plus or minus 5 plus or minus 10 area. If the fluctuation is more, then your molecule may the compound which you have docked may go out of the pocket and not able to uh, fit into the pocket for 100 nanoseconds. Okay, after that, another one is hydrogen bonding. This most of the reviewers ask about this, that give us the hydrogen bonding graph, that how many molecules in your ligand molecule during of your ligand molecule and your receptors amino acids, how many hydrogen bonding are forming during the MD simulation can be represented with the help of this graph. Okay, so these are some MD outputs. So now these are the final results which we obtained from MD simulation. If you have any kinds of doubt, you may ask, and related to docking, related to MD, you can ask. Feel free to ask, and please write your. You can unmute yourself or write your comments in your comment section. Hello. Yes, Sumit sir. Hello.
Yes, sir.
Sir, my MD whole workflow is completed. Okay, sir. So I am ending it the hydrogen bonding graph, and I have demonstrated all the results that we are getting. So if anyone is having doubt, please feel free to ask.
Sir, someone may asking for the file.
Okay. Yes, sir. I will share the command line file with you. Shivraj sir, no, you cannot be able to do with the Gromec website as you require the GPU and CPU. As I have demonstrated you that even my laptop is not configured to run the MD. If I will start the MD in my system also, which is having 16 GB RAM and all, it will take a month to complete a 100 nanosecond run. You can collaborate with other college, and Sumandi Vidyapita is also having the facility of the MD run. You can collaborate with us.
Is there any other question? Sir, one student question is also there related to Autodoc. He is having issue in installing the software.
Okay. So Autodoc software, or please unmute yourself and please give me your query. Because Autodoc software cannot be visible. Actually, sir, what is happening that the Autodoc software is not visible in the command line. Okay, so it will show only the icon at your desktop, and if you have not enable the icon directly installation, so you cannot see the Autodoc icon or the app icon in your desktop. Which type of problem are you facing? You can share your screen and please let me know. Yes, Shivraj sir, this is the problem that mainly laptops faces, because even you are having the Ryzen 5000 series configured laptop, the RAM, or we can say GPU requirement is less. Okay, so the MD run may shut down your PC, or it may uh, increase the workload to the GPU and your CPU. Okay, so it will immediately shut down and it may stop your PC also. Please don't try. I recommend that, because your motherboard may vanish with by running this command again and again. I have told you that up to the command line of energy minimization you can run in your PC without doubt, but uh, for final MD, NVT, NPT, and MD run, you require the system or the high configuration PC. Okay, The next question, Pratibha.
Can I answer question?
Yes, sir.
Okay, Pratibha, you asking that what is the requirement configuration or how can the right configure for MD analysis system? Okay, so finally the MD analysis is depend upon uh, what is your runtime. Say for example, you are running for 100 nanosecond. Okay, or also it depend upon the your protein size. How many molecules of protein or how many amino acids are in your protein. So both these factor matters. So ultimately, as of now, the NVIDIA RTX series of a 5000 or NVIDIA A series, ADA series of 4000, 6000, at least of 16 GB GPU is minimum required for running a smooth MD simulation, as well as your CPU must be of a अगर आपको पता होगा तो सीपीयू जो होता है प्रोसेसर उसमें लास्ट में एक कोड वर्ड होता है, कोड होता है एच के एच एक्स। तो एच एक्स है तो परफेक्ट है, वो हाई परफॉर्मेंस टास्क के लिए असाइन होता है। तो उसके लिए आप इंटेल का i9, एटलीस्ट i9 कॉन्फ़िगरेशन में जो सीरीज है कोई भी आप ले सकते हो, और एटलीस्ट 128 GB रैम आपको चाहिए। 128 GB रैम इट इज आइडियल। तो ये सारे जो आपके अगर ये कॉन्फ़िगरेशन जैसे 128 GB रैम, i9 और Xeon प्रोसेसर and along with the minimum of a 16 to 8 GB of GPU, any RTX NVIDIA series, that will run your MD simulation smoothly. You can finish the 100 nanosecond of MD within a 12 hours to 24 hours. Otherwise, नॉर्मल हमारा जो लैपटॉप होता है, जैसे अभी मेरा ये लैपटॉप है, लिजियन है, विच इज हैविंग 4 GB ऑफ NVIDIA graphic card and 32 GB of RAM, till it take days or month to complete the 100 nanosecond MD simulation. So configuration is most important here. As I think most of you have been asked the question that why the MD simulation in nanosecond, why the GPU is required. So I hope Jai have solved your queries or answered the questions. The main requirement of GPU is that when the protein is having the amino acid and amino acid having the different elements. So in MD, all elements are to be what I can say that the trajectory has been measured by GPU. And this data of energy calculation, everything done by CPU. So both the tasks are done simultaneously. That's why GPU and CPU both is required in a high configure way. Then one more thing I just want to clarify it, that whenever you are running MD, Linux OS is preferred. Okay. Why it is so that because the force field we are using, okay, along with the graphic card we are using, the power supply and consumption of a power which is required, that can be configured in a Linux easily. Okay, the Gromex software is designed such a way that the energy, power consumption, temperature, everything has been configured in such a way that Gromex run in a Linux easily. While you are running Linux in a Windows, so that much of power of CPU as well as that much of a utilization of your RAM and everything, that is not perfectly aligned or perfectly used. That's why this is the limitation of a running Linux in Windows. Instead of, I advise you to run a Linux as the additional OS in your PC, then run the Linux system and then run MD in the entirely in a Linux, not through window. So that is my advice.
Is there any other questions?
Jai, have you cleared about the our configuration, our systems configuration and everything?
No, sir, I have not covered our system configuration, but I have shown them that how to run MD
Okay.
in our system. Please continue, sir.
So Sumit sir, I am just clearing one thing that
Sure, sir.
yeah. So as Sumit sir and myself and Jai, we are open for collaboration. So we have high configuration PC in our institute that is of a 128 GB RAM along with a i9 processor and 16 GB of a graphic card. Okay, NVIDIA A4000. So in our system, we have entirely run on Linux. So if anyone, any student or any faculty or want to collaborate with us and to finish his MD run job in our with us, we most highly welcome them and we are open for the collaboration. Sumit sir is also having the collaboration with us. So myself and Sumit sir are open for the collaboration. Sir, you can share your views also.
Yes, we are ready for the collaboration for any work related to drug discovery as well as cell line analysis. So if anyone want to collaborate with us, you can directly mail us or WhatsApp us. We are ready to collaborate.
Dear participants, as we reach the end of this 1 week workshop, I would like to express our heartfelt gratitude to everyone who contributed to its success. Our sincere thanks to our respected chief guest, Dr. Hemant Kumar, for inspiring us through this inaugural address. We are deeply grateful to our guest of honor and lead resource person, Dr. Ghanshyam Parmar, for this outstanding lectures, guidance, and continuous support throughout the workshop. Our heartfelt thanks also goes to Mr. Jay Mukesh and Mr. Bhuvesh Bania for conducting these practical sessions and patiently guiding all the participants. A special thank you to every participant. Your enthusiasm, dedication, and active participation made this workshop successful. Before we conclude, I would also like to share something exciting. The wonderful response to this workshop has encouraged us to organize more advanced training programs in the near future. These programs will include topics such as advanced network pharmacology, advanced molecular docking, molecular dynamic simulation, artificial intelligence in drug discovery, scientific writing, research paper writing, manuscript editing, journal selection and publication guidance at, at Thyme Phytobiomed Private Limited. We are committing to support researchers beyond this workshop. Along this workshop, we also provide online advanced training, one-to-one mentoring, and academic support for research paper writing, manuscript editing, journal selection, publication guidance, research projects, and scientific communication. If you are interested in any of these programs or services, you are most welcome to connect with us. The detail of our upcoming workshop will be shared soon through our official WhatsApp group, LinkedIn, and other official media platforms. We hope to meet you again in our future learning programs. Finally, on behalf of Thyme Fighter Biomed Private Limited and AdGrow Foundation, I sincerely thank all our speakers, guests, participants, and the organizing team for making this workshop a grand success. Your support and trust mean a lot to us. This may be the end of this workshop, but we hope it is the beginning of a long academic and professional association with all of you. If you found this workshop helpful, we kindly request you to share your experience with your friends, colleagues, classmates, and fellow researchers. Your recommendation will help us reach more learners and continue building a strong research community. We wish you all success in your academic, research, and professional journey. Stay connected, keep learning, keep researching, and keep growing. Thank you once again. Have a wonderful evening. Jai Hind.
इसका लास्ट का क्या था, क्या बताया रह गया है?